Hi, today I'm excited to introduce functions of SpatialView. So this is our paper currently on bioarchive. And SpatialView is a browser application that facilitates visualization of data from a spatial transcriptomics experiment, which we will refer to as an ST experiment. Currently, SpatialView supports 10x vision, and although a user may view other types of data as well, today we will focus on data from 10x. As we'll see, SpatialView has a number of features that are very useful when visualizing data from individual slides, and especially for comparing results across multiple slides. When there are multiple samples, SpatialView expects the data is normalized and integrated across the samples. How exactly the data is normalized and integrated depends on user's choice. As long as the data is normalized and integrated, everything will be fine. Okay, now let's proceed to introduce SpatialView in detail. For this demonstration, we will consider 10 ST samples from Buckley et al.'s counter study that was published in Nature Genetics in 2022. So this is the paper. So here on the top of the SpatialView page, you can see 10 H&E image. Those are the H&E image correspond to our sample used in this demonstration. The data from that study was pre-processed and analyzed using Surat. If you'd like to see the details, they are given in the supplementary material of our SpatialView paper. The processed data is stored in the data directory of the application, and SpatialView has a command to help us transform our data from the data directory to this web application. So detail of this part has already been covered in our previous tutorial, so this time we will focus on how to interact with SpatialView web browser to help us better visualize and understand our data based on our analyzed results. Okay, so we already discussed the samples on the top of the page. One thing I want to add is you can see as I mouse over different samples, there are sample information right below each sample image. So in our data, we have 3 breast cancer sample, 2 gastrointestinal cancer sample, 1 liver cancer sample, 2 ovary cancer sample, 1 pancreas cancer, and 1 endometrium sample. And below those sample images, you can see there are multiple tabs. So those are different SpatialView's main pages. So the first page is individual visualization. In this part, you can select your individual sample and visualize them individually. And in the dimensionality visualization, you can visualize your dimension reduction results. And in the group analysis part, you can form your group and visualize some group analysis result. I will talk about this page one by one. Oh, and for the data and tutorial page, those are the links for our tutorials and some reference information and our data information. Okay, I will go over each individual pages one by one, but now let's first focus on individual visualization part. So firstly, in the top middle part, you can see 6 colorful buttons. Those are the 6 clusters we previously identified. And then you can see that in this middle image, different spots are colored based on their cluster membership. And you might already have noticed that as I mouse over different spots, there is a H&E image on the right hand side, moving together with my mouse. So this is the zoom-in H&E image corresponding to my exact mouse position. So this function helps you to visually check whether your cluster is biological meaningful or not. For example, if we are interested in checking cluster 2, then we can mouse over some green spots. For example, those regions. And You can see that from the H&E image, the green spots indeed looks different from other spots. And if you check with the pathologist, he or she will tell you that those green spots are actually tumor regions. Once we verify that all clusters are indeed biologically meaningful, we will want to check the marker genes corresponding to each cluster. To do that, here on the right-hand side, we provide you a list of marker genes corresponding to each clusters. And to check the marker genes expression, you can just click on their names. You can see on the middle part, here is a heat map of that marker gene's expression across the whole sample. And to switch between different marker genes, you can just click on different marker gene's name. Also, if you want some different color, you can just click on this brush and then select some different color bar. For example, if you want to select this one, you can just click on that color bar and then re-click any gene. Now the new color bar is applied. And you can clean your gene selection by clicking on this eraser button. Now let's change the color map back. Also, if you are specifically interested in any of the gene, you can just search it. For example, let's do this one, APEX1, and click on this search button. Then your search gene's heat map will show up again in the middle image. And again, you can clean gene selection by clicking on this eraser button. Okay, so on the right-hand side, it provides us a way to check individual genes expression across the whole sample. Then what about focus on one spot and check the expression of the whole marker gene list inside that spot? To do that, we can use the heat map on the left-hand side. So what you can do is, for example, if we are interested in this spot, you can see that this spot is a blue spot, so it corresponds to cluster 3. Also, you can also verify it by looking at the tooltip window above the image. You can see it tells you the cluster membership of the spot you are pointing at. So cluster 3, it also tells you the top 5 highest expressed gene at that spot. So in this spot I'm pointing at, the highest expressed gene is IGKC, and the second highest expressed gene is TMSB10. So to visualize the marker gene list, the whole marker gene list expression inside that spot, what we need to do is, firstly, we click on this spot. Now our spot selection is freeze. You can see now I mouse over different spots. My spot selection remains the previous spot that I click on. And then we can use the heat map on the left-hand side. So this heat map is the heat map of the list of marker genes, exactly same as the marker gene on the right-hand side. So different small box represents different marker gene. So you can see the first spot is GPSM2, and if you check on the right-hand side, it is also GPSM2, and this one is highlighted in red on the right-hand side. Similarly, I move to the second box. It is ANKF1, and similarly on the right-hand side, it is also ANKF1 and also highlighted in red. So this is a heat map that corresponds to the same list of marker genes we present in the right-hand side. And on the left part, there is a color bar, green bar, and together with a number, this tells you the cluster membership of those genes on the right. So it tells you for those genes, they are cluster 2's marker gene. And similarly, for those genes here, they are cluster 3 marker gene. And similarly, for those genes here, they are cluster 5 marker genes. As you can remember that we selected a spot that belongs to cluster 3, and also based on the marker gene expression, you can also see that the marker genes belongs to cluster 3 also frequently get highlighted in this spot. Also, if you want to unfreeze all selection, you can just click this button. Now everything is go back to default. I also want to introduce some small functions and features in this individual page before we go to other pages. So firstly, for those colorful buttons, you can see as I mouse over different buttons, different spots corresponding to my selected clusters are highlighted. And we can fix highlight some of the clusters by just clicking it once. Now, if I mouse away from the cluster button, you can see cluster 2 is still highlighted. Similarly, we can also highlight several clusters together. For example, let's also highlight cluster 3 and cluster 5 by clicking them once. Now both 2, 3, and 5 is highlighted. We can also hide several clusters by double-click them. Now let's double-click 0, double-click 1, and double-click 4. Now we hide cluster 0, 1, and 4. By doing that, we provide you another way to visually check whether our clusters are biologically meaningful or not. To do that, we can adjust the spot opacity by changing here. You can see that cluster 2, 3, and 5 pretty much covering all the dark region on this sample. And if you check with the pathologist, he or she will tell you that those dark regions are actually indeed tumor regions on this sample. So basically, it tells you that cluster 2, 3, and 5 covers all the tumor region of our sample 1. And if you want to change all the cluster selection back to original, you can just click on this reset button. And now everything go back to the original. Okay, now let's go to dimensionality visualization part. So here is a UMap summarizing all the 10 samples. It is get by integrating all the 10 samples together and then perform UMap. And then if I mouse over different samples, you can see different spots got highlighted on this UMap. These highlighted spots are the spots that correspond to the sample that I'm currently pointing at. So for example, those highlighted spots correspond to my GIST2 sample, and now those highlighted spots correspond to my LIHC1 sample. And currently I'm selecting BRCA0, and if you press the toggle view button, you can see the whole UMap transform into subset of spots that form my BRCA0 sample. Let's see that. Okay, now let's see that again. So basically, you can see that firstly the UMap subset of some spots, and then those spots form my BRCA0 samples. So this is a dimensionality visualization function. And another thing I want to tell is that this, again, we can search gene here. If we, for example, if we search TRAC gene, that is a gene identified as a marker gene for cluster 3. So if you can see, here is the cluster 3. Let's search it. You can see the expression of this gene across the whole UMap. And then you can see again, it frequently gets highlighted in this part, a subpart of cluster 3. Okay, so this is the main functions of the dimensionality visualization. Now, in addition to dimensionality visualization and individual visualization, spatial will also allow us to analyze and visualize multiple samples by forming groups. We have the flexibility to determine how many groups we want. In our case, let's say we want 4 groups. One is breast cancer group, one is gastrointestinal group, one is liver group, and one is ovary cancer group. To form groups, you just drag different images, sample images, into different group boxes, like what I just did before. And once we created groups, we can click on whatever genes we are interested in, or search whatever genes that occurred in our mind. And you can see here is a heat map of our selected genes show up in the middle. This heat map compares that gene's expression across all the groups. In this heat map, the groups are separated by this vertical thick black line. So this is breast cancer group, this is gastrointestinal cancer group, this is liver cancer group, and this is ovary cancer group. Each row represents a cluster, and for each small box, this heat map shows the average expression of the selected genes in each cluster for each sample. So for example, in this box, it tells us that PAT117 gene has normalized average expression of 0.07 in cluster 0 of sample BRCA0. Also, when you mouse over a specific rows, you can see below here is a t-test performed based on that row across the groups. So for the t-test, you can see it is comparing different groups pairwise, and it is compared based on the expression of cluster 0. For the t-test, the average expression value within groups are used, as in a pseudobulk approach. And the summary statistic and the t-test results are shown in this table. To perform a t-test, there should be at least 3 samples in one of the group and at least 2 samples in the other. So you can see in some comparison we don't have t-test results because we don't have enough samples. The adjusted p-values are adjusted based on the Bonferroni correction using all the genes in the dataset. You can check the box plot. So in this box plot, you can see on the x-axis, different numbers represent different clusters. On the y-axis, represents the normalized expression of that gene, and different color represents different groups. So each dot corresponds to a spot inside that group, correspond to this cluster. So for example, this dot that I'm pointing at means that there exists a spot. It belongs to group 1, it also belongs to cluster 0, and it has normalized gene expression of 1.84 for PAT117 gene. Also, on this part, you can see I have different tabs. So this one is modules gene regulators. Those are the genes get from the Berkeley's cancer study paper that they think those genes are really important. You can again click on different genes' name and check their box plot and heat map correspondingly. So SpatialView allows us to have the flexibility to upload whatever genes we are interested in a CSV file. You can just click on this upload button and then upload a CSV file containing all your interested genes. You no need to worry about any format. SpatialView will automatically detect those gene names. For example, I previously uploaded a CSV file, and then you can see here is my genes. that I want to check. And if I click on the gene name, you can again see the heat map of the gene I'm clicking on. You can perform genome-wide comparison using all the genes by clicking on this Run t-test button. But note that this may take a while and the browser may be frozen during processing. Additional filters here can help you reduce the number of comparisons. Just click this Run and Download button and wait for the results. Okay, those are the main functions of SpatialView that I want to introduce. And please note that I haven't included all the functions of SpatialView in this tutorial. If you are interested in more detailed things, you can check this user guide in our GitHub page. And in this user guide, we have all the detailed functions listed here with detailed explanation. So we hope you enjoy this tutorial, and we hope you find SpatialView to be a useful tool. Please don't hesitate to reach out if you have any questions, and thank you for listening.